Okay, Monday, we're having a replacement holiday. So we need to do replacement class for 2 hours. We will do on week 4, we'll be using the lab slot to do the replacement. The venue, your Thursday after 10, where you are? No class. Okay. Okay. Or you want to do another other day? Tuesday? Or, oh. Or Monday? Oh. Tuesday, 2 to 4. Tuesday, 2 to 4. Can. But now your calendar have class lah. Okay. Wednesday? Full. Wednesday full. Okay. Then we do Thursday. We're using the lab slot. This one in week 4. We are now in week 2. Next week, Thursday is Taipusam. Okay. So we'll do next week, which is week 4. We'll use lab slot. 8 to 10. Classroom. Classroom, maybe we'll be using we're using lab lah. But next week, I will let you guys know the location of the replacement class. Okay, so yes.
And for material is up to the Chinese.
Yes. For statics, it's different lecturer handling your lab. So you need to ask the lecturer. Okay. For material, lab, both lab and class is under me. So okay. Right. Let's just pass around. Okay. Okay, let's start our class. Right, previous class we stopped at this spectrum, right? So C equal to F lambda. C is speed of light, frequency. F lambda is a wavelength, right? So we expect you to remember what is C, what is speed of light, like what you remember for gravity, 9.81, right? Then we derive from here by using Planck constant, 6.63, 10 power negative 34. Usually Planck constant will be given in the question. Then you need to write this equation. Energy equal to F frequency multiplied by the H, which is the Planck constant. Then you rewrite this equation, or you rewrite this equation, depends on what is missing. Usually frequency will be given, or sometimes not given. So you have a C equal to F lambda, you have 3 parameters here. Then E equal to F H lambda, you have another 3. You combine these 2 equations, you have 5 different parameters. So this is 5 different parameters. So something will be missing in the equation, depend on the Tesla. So these two are important equation. So just a reminder, every time when you solve question, don't just give me numbers. Write equation first. Write any general equation first. Then only you substitute. Okay. So C equal to F lambda, E equal to H multiplied by Planck constant. All right. So again, this is just a elaboration of these two. Sometimes this equation, you don't need this one, but you need to be smart enough to change between this one and this one. Okay. All right. Now today we look into the Bohr's theory. Before that, in our first class, we mentioned Bohr's model. What is Bohr model? You need to know how to draw nucleus and the electron. Okay. So based on this Bohr's model, you have a nucleus inside. You have this is nucleus. Then this is orbit number 1, orbit number 2, orbit number 3. Okay. So you know that electron is the one can move from orbit to orbit while the nucleus will stay. So how to make the electron moving from one orbit to another orbit is that either we take away energy or we give energy. So this orbit you imagine as a highway. All right, if you have a driving license, then you imagine this orbit for the electron as a highway. So same like your road for Malaysia context, maybe overseas different. On the highway, you want to go slow, you go to the left or right? Left, right? Let's say you have 3 lanes. Your car is here. You want to go slow, you go to left, right? You want to go speed, you want to overtake, you go to the right, right? Same law apply in the entry materials Bohr's model. So if you want to make the electron moving from one orbit to another orbit, with this, if you want to change length for number 2, okay, and number 2, n is a number of orbit. If you want to change 2 to 3, you give energy. Mean you press on the pedal, you give more fuel, you give more power, then the electron will jump from 2 to 3. Okay, so same. If you want to change length from 3 to 2 or 2 to 1, you absorb energy. Sorry, you release energy. Yeah, so these are the two basic fundamental principle if on how the electron moving. Previous class, we show you how people manipulate single atoms with a short movie, right? You still remember? There's a short movie, a small clip. How the scientists manipulate the electron for moving, actually giving energy and absorbing the energy. So when the electron move from 2 to 3 or higher orbit, they need to absorb energy because absorb energy give more energy. If they want to change from number 2 to number 1 or lower orbit, you need to let go of energy, mean you release energy. So these are the two basic principles. Okay. So these are the two keywords that we expected you to write in your answer, either this one or this one. So if you are meaning for receiving energy, please use energy absorb. Please use this keyword. If you mean you let go energy, please use energy. Yeah, in your answer, you write electron let go energy, give you wrong answer. You have to use this keyword in your test or final exam. Okay. So first notation, N we represent as orbit in Bohr's model. And N equal to 1 is the lowest energy in the models, right? So you cannot go lower than 1. You go lower than 1, you become nucleus already. Okay. So N equal to 1 in other textbook also means ground state. So if it's in the question, if the question mentioned, find the energy for the electron to drop from orbit number 3 to ground state, mean we expect you to calculate from n equal 3 drop to n equal 1. Okay, so remember ground state is n equal 1. N equal 1. So in test, I still can help you a little bit, but in the final, don't ask the invigilator to call me to ask what is ground state. I will just ignore you. Okay. So the rest you read. Okay. So this slide is just mentioned. This is orbit number, okay, number 1, number 2, number 3. So let's say the electron move from 3 to 2. 3 to 2, it release energy. 3 to 2 release energy. The amount of energy released will be equal to the energy it required to jump from n number 2 to number 3. Yeah, the same energy is needed to jump from, if you switch lane from number 2, number 3, it will be the same. All right, 2 to 1, another amount of energy. Okay. So if the question mentioned proton, it just means you need to calculate the energy released in the form of electromagnetic radiation in the specific wavelength and energy. So if the question mentioned proton, it means we expect you to calculate energy that is being released. Release means it changed lane from higher orbit to lower orbit. Yeah. So if you see the word proton, means it changed length into lower orbit. Means you move like highway, you move to the left, it become proton. Okay, proton is released. Proton release. Here it mentions specific wavelength and energy, and there's a energy here, specific wavelength and frequency. Recall these two equations that are on whiteboard. C equal to F lambda, E equal to F and Planck constant. E equal to F dot H. Right? And then you refer to the chart either by colors. If you fall into the visible spectrum, then you need to tell me what color you are seeing or expecting. Okay. So this is another illustration. How to read this graph? You read the axis, the vertical axis is the energy in the unit of EV. EV is electron potential. As what you learn in your circuit, V voltage is potential. Means V equal voltage actually is delta V. You make comparison with, you take voltage 1 minus voltage 2. Right? So it's a difference of energy or voltage on this here. So here energy is in EV. Remember to write the unit. If the question asks you to calculate photon energy in the mechanism or in the movement of electron, then remember to write EV. Right. Now all these colors you see if it's in ground state n equal 1, this red color, it will be minus 13.6 eV. Okay, it will be minus. Then orbit number 2 will be minus 3.4. This is for hydrogen atoms. This graph is for hydrogen atoms. Okay. Now to make a jump, electron to make a jump from n number 2 to ground state, what is the energy needed for the electron on the hydrogen? What is the energy it needed? This layer is minus 0.3 energy here. Means the energy inside the orbit or in the electron is 3.4 or minus 3.4. In the ground state is minus 0.6 eV. So what is the energy needed for it to jump from n number 2 to n number 1? What is the energy? What is the potential I mentioned just now? What is potential? Huh? What is potential? Again, I don't wish to see you in next semester. So what is the energy to jump from number 2 to number 1? Huh? 8.2. 10.2. What is the unit? EV. How you get 10.2? Negative 3.4 plus. Okay. So how you get the difference from something? How you get differences from something? How you know the length from this position to this position? You take what? Last position minus early position, right? Correct. Correct. So here I write E number 2 minus E number 1. So E number 2 is what? Minus 13.6 minus EB is what? 3.4. So here is plus, minus is plus. So you get minus 10.6 EV. Sorry. 10.2 EV. So just now, yeah, 10.2, correct. So you see the negative sign here. It means if it drop from higher to lower, you get a negative sign. It means it release energy. Okay. So if you see a positive, means you give energy. Understand? Okay. Now, if you see number 3 and number 4, number 3 and number 2. So if you understand what is the energy it need for the hydrogen electron at orbit number 3 drop to number 2, what is the energy? Huh? 1.9. How you get this answer? You take minus 1.5. Why you take minus 1.5? Again, how you find the differences between two places? What is your concept? You talk about general equation first. Huh? You take E1 minus E2. What I write on whiteboard here? What I write on whiteboard here? What I write here? No. What do I write? What do you see here? What I write? What you see here? E2 minus E1. What does it mean? Starting position, end position. How you know the distance between these 2 points? You take final position minus early position. So how come you take minus 1.5 minus this one? What is the end position? Huh? What is the end position? End position still 1.5. You understand my question? I think the rest already understand. This is n number 3, n number 2. What is the energy at n equal 3? Negative 1.5 EV. N equal 2 is minus 3.4. The electron dropped from 3 to 2. What is the n location? N equal 2. Early position. So again, how you find the difference between two places? Huh? Change of energy equal E2 minus E1. So what is your E2? You don't understand what is E2 or not? No, E2 and E1, you understand what is the meaning of E2 and E1 or not? Okay, two distance, starting end. How you find distance between start and end? You take start minus end. No, we start end minus starting. How you measure here to here? You use a ruler, right? You start from what? 0 to something else. So how you know the length of this one? You take n minus starting point, right? You understand, right? Same. You know you drop from 3 to 2. What is your n location? Look at the whiteboard here. Look at the whiteboard here. Don't look at there. Look at here. Your electron dropped from 3 to 2. If you still can't understand, maybe your classmate need to teach you already. They already know. It start boring already. What is the n location? N2, correct. Starting location is here. So to find the change of energy or energy needed, you take n location minus start location. Okay. You confused. If I write n equal to, n equal to, this is n equal 3. You understand? Or I write n position minus start position. This is mathematics. This is a mathematic notation. If you don't know this one, you need to go and polish your mathematics notation. So what is energy at number 2? Minus 3.4 minus 1.5. So what is the answer? Positive? Positive? Huh? This is the careless mistakes we see in the test or final exam. Don't repeat this module. Don't repeat this module. Minus 1.9. Agree or not, class? EV, Okay, now the question is, what is the energy needed? Okay, this one minus, what does it mean? Let go, emit or release. Okay, again, I don't use the word let go. You can either use emit or release. Okay, now the question now, what is the energy needed for the electron to jump from n number 2 to n number 3? What's the energy needed for the electron to jump from n number 2 to n number 3? What's the answer? 1.9 EV, positive. And positive means what? It receives energy. So how you prove this one? Same. If you jump from 2 to 3, same, you write delta E. Delta means change of energy. Equal E2 minus E1. Of if you cannot remember this one, you just write E n number 2. Number 3 is the n location. N equal 2. Same. Write properly. Okay. You can either use this one or this one. Okay. Okay. Now for engineering module, please write general equation first. Don't straight away give me numbers. Don't write delta E equal to minus 3.4 minus bracket this one. I will put question mark what you are calculating. Okay, write general equation first. So here, E2 is here. If you jump from 2 to 3, so this one will be minus 1.5 minus 3.4. You get positive value 1.9 EV. This one is receiving, not receiving, absorbing energy. Means you give energy to it. Okay, this is how you know, and this is the differences between positive and negative answer. So in your question, in your solution, please check your answer when it comes to energy. So there's a difference between negative answer and positive answers. Okay, I think the rest you already understand. Now, A side you already understand from this figure, you already understand already. This one is for hydrogen. Other elements have different value on the y-axis. Okay, let's look at B. Later, what we will do is that we will study the splitting of the lane. Like for example, this red color, the ground state only have one lane. Highway number 2 or lane number 2, you will see 2 lane. Highway lane number 3, you will see 3 lane and so on. Okay, we'll go deeper. The rest you read. Okay, now there is a energy, there is an equation for hydrogen electron. There's an equation given here. Okay, E equal to 2 pi square me power 4 divided by n2 and Planck constant number 2 square. You simplify, you substitute the Planck constant, you put in the mass of the hydrogen, which is 1. Energy constant, E, you substitute, you get 113.6 divided by n squared. And it's a negative. So this one is for hydrogen. So okay. So what else? So 1 EV equal to so and so joule. So this is a conversion of EV. So just now we already done one exercise on the EV. So 1 EV will equal to minus 19 joule. It means this joule is when you burn something, right? You burn petrol, you burn something lah. It will give you energy. So this is a joule, right? Okay. So as you can see on this diagram, from ground state and then N number 2, you'll see the word Balmer. N number 3 will be Paschen. N number 4 will be Brechet, will be P found, and so on. So from your calculation, you need to tell me what is the let me see. Okay, the rest you read now. Okay, so this one is the name of the layer from where it dropped. So means if the energy, if the electron, no matter where it formed, it drop. If it drop at ground state, the behavior is called Lyman or Lyman. If from outside any n numbers, it drop to number 2, the behavior called Balmer. Anything happen, it drop to number 3 or it stop at number 3 or orbit number 3, it called Paschen and so on. Understand? Yeah. Right. Now, again, I already uploaded tutorial question in the Canvas. All these features already inside the Canvas. So download and put it as your notes in the class. You don't need to copy all these things. You just need to fill in the blanks in the tutorial question. Okay, the rest you read. So if the energy is positive, means energy absorbed. If the energy negative, less than 0, it is a release. Okay. So to use this equation, basically you remember energy equal to 1.6 N2. Again, this is for hydrogen. It's for hydrogen. Just to highlight how to calculate the energy. Final minus initial. Or you can write 2 minus 1 or N equal to what orbit to another what orbit. But I think if you write orbit, you might confuse yourself. So it's better you remember as final minus initial. Okay. So you can expand this equation for hydrogen. So you know that E equal to 13.6, 1 over N square. So you can find the energy by this equation, right? If you don't have the chart, right? If you don't have the chart, you only know the orbit number. So you can use delta E equal to minus 13.6 bracket 1 over N square minus 1 over N square. Yeah. Again, this equation is important. Yeah, maybe I'll write here. This is delta E equal minus 13.6 N square. So, or E, or E. Okay. Delta E equal to E2 minus E1. Okay. So this is just an illustration how you calculate the energy. If it jump from 2 to 1, 2 to 1 means you need to release energy, means release load already. Release load will get what? Negative. Okay, at the end, you'll get one value minus 10.2 EV, which is we read from the graph just now. Just now, the question I asked you, you get minus 10.2 EV. This one you read from the graph. But let's say you don't have graph. In the exam, maybe this graph is not given. So there's a way to calculate the energy to jump from one orbit to another orbit by using this equation. Right, this equation. Okay. So the answer will be the same if you check the chart. Okay. So the wavelength of the proton, again, release energy. You release photon, not proton. Photon, PHOTON, photo, electron, photon. And earlier, we know the energy equal to C divided by lambda H. You rearrange the equation because wavelength, this one you can read from the chart. So we rearrange this equation E equal to C divided by lambda Planck constant. So you move lambda to the left, move E to the right. You substitute the value. E you can find from the equation just now. Planck constant will be given, or sometime if it's not given, then I will let you know. Okay. C, speed of light, assume you already know. You substitute the value again. Speed of light, we already assume you know. So lambda, you substitute. Energy is here, and then you substitute. This one, the E here, we take the magnitude on. Lambda don't have negative value. Okay, so E here, we take the magnitude on. Because you know that for this case, it jump from one orbit to lower orbit, you get negative value here. But to calculate lambda, again, we take magnitude of the energy. That's why you get positive value. So here you get 120 nanometer. Nano is 10 power 9. So go to the chart. If you have this one, you have the lambda already, go to the chart and check. So you go to this chart given in the last page of the question paper. You go to the last chart. You already calculated the wavelength. So 120 nanometer, where is it? Where is it? Where is 120 nanometer? Can you read from here? Can you see? Cannot. FM radio here. Okay. What is the unit on the chart? Nanometer. So don't need to worry about it. 120. Where is 120? It's here. Here is 10 power 7. It's not here. FM radio is 10 power 9 already. Okay. So 120 nanometer, go and read. The scale here is nanometer, which is correct. You only need to go and find where is 120 on this line. Where is 120? Here is 1000. This is 10. So it's about here. Understand? Who cannot get it? Who don't understand why suddenly 4 here and not here? So you need to know how to read the scale. So it's about there, about there. I just draw the line. So 10, this is 10 power 1. So 10 power 1. So here half is 10 power 2, right? So this is 10 power 1. Between these two dots is half here. Here is 10 power 2. 10 power 2 is 100. So this 120. So a little bit off the center. Then you draw a line. You draw a line, then you tell me what is type of the radiation and so on. So is what type of radiation? Is beyond visible light and moving towards what? Ultraviolet. Means it's here already. Here already. So if you move to the left, it will fall into ultraviolet. Means you cannot see it. You cannot see it because outside the visible light wave. So you cannot see it, but you'll start to feel hot already. Start to feel hot. And the emission is quite fast. Ultraviolet sun is about the sun lamp, so on, right? So ultraviolet is you go to the beach, you go sunbathing. It's the effect. Okay, so it's about ultraviolet range. Okay. Okay, let's do this short exercise, then we have a short break. Okay, so hydrogen atoms exist with this electron in state number 3. Electron undergoes a transition to N number 2 state. This one already know. Actually, I already got you since the beginning of the class. So calculate the energy responding to the responding photon. You see the word photon, you already know already. The answer will be negative. So the frequency, I will show you. Wavelength, use this one. This one. C equal to F lambda. You substitute here. You get E equal to C divided by lambda H. Right? Energy absorbed or emitted, you already know. Which series does this belong and what type of emission does it represent? So there's a standard SOP here. So you write equation, what is energy equation, then you substitute accordingly. You find the frequency, then you can find the wavelength. Frequency is here, either speed of light or lambda or energy, right? This one. This one. This one. You mean this question? Okay. I'm showing you the answer. Yes.
For the photon itself that has been released, the energy is positive, right?
Photon is actually a behavior. It's the energy. It's a name for that energy. Right. It jump. Let's say it jumped from 3 to 2. There's an energy emitted here. The energy is called for photon. It's a name. It's just a name. It's just a name for it. Okay. Right. Now in this case, n to 2, you release. So you use the equation delta E equal to E2 minus E1. Why you cannot use E2 minus E1 is because you don't have the chart. In this question, the chart is not given. So solution, you can use this equation minus 13.6. Again, 13.6, this one is applied for hydrogen. If it's not hydrogen, you need to go back to this equation and substitute accordingly. You need to use this equation to substitute accordingly. Okay, so M, where you find the M, go to the periodic table. Below there is a number. Last lecture we focus a lot in the the weight of 1 mole of that element. Okay, E, there's a constant value. You can find energy value, right? Then H, Planck constant is there, so you just substitute. So for hydrogen, M is 1. This one, actually, I forget what is the number, but you can find electron constant. What is the electron constant? For 1 electron, there's a value there, right? So if the question changes to another element, all the missing parameter will be given. For example, the constant for E, the constant for Planck constant will be given. Of course, you see periodic table in the test, so we expect you to substitute the M from the periodic table. Okay, so the first section is just substitute the value. So again, write general equation first, then only substitute. Don't straight away give me these numbers. Put question mark. So where you get this one? Where you get this one? What is this value? Okay, write general equation first, because this one will cost you 1 to 2 marks just to write this equation. Can, as long as there's an equation. As long as there's an equation. Okay. Right. So you substitute accordingly, you press calculator, you get minus 1.89 EV. The answer for the first section A is minus 1.89 EV. Again, remember the unit. remember the unit is EV. It's a potential, it's a potential. So 1 EV equal to so many joules, 1 EV equal to how so many joules. The question asks you, it can be two types of answer. One is either in EV, one is in the joule. One in the joule. So if the question asks you joule, then you multiply this number to the EV, right? 6, 10 power negative 9. You substitute, you get in joule unit. Okay. All right. Now, be sensitive to the keyword in the question. If you see energy, most of the time we expect in the unit of joule. If the question asks you about potential energy, then the unit is in EV. Okay. But it depends. Sometimes if you score quite bad, you stop at here, I still help you a little bit. Okay, frequency, once you have the energy, you substitute into the frequency. E equal to F Planck constant, or FH. Then you flip the equation. You move F to the, either you remain F, you move the H to the left-hand side. You will see the equation like this. So you just substitute the previous one inside here. Okay. Then Planck constant is 6.6 10 power negative 34 joule second. When you need to use Planck constant, you are using joule and not EV. So if the section A, you stop at EV, the answer can be correct. If you answer in section A, you still start at EV. But when you come to section B, if you still use EV, then answer already. Why? Because you are multiplying a Planck constant with a joule and second. So EV and joule doesn't communicate. You need to convert EV into joule, then only you can cancel the dimension in your calculation. Make sense, huh? Okay. So that's why you need to understand the general steps first. Okay. Again, remember to convert. If you convert the energy into joule, if you want to calculate frequency, because you are using Planck constant. Okay. At the end, you arrive at frequency is 1/2. It's a hertz, or you can just straight away use hertz if you want. Yeah. So remember on a unit, it must be synchronized or homogeneous. So just remember that. Okay. So just write this one equation. Right. Again, you'll see these slides later. I'll upload in the Canvas. Important you understand why we do so, and there's a reason behind that. Okay, once you get this hertz, the next value, one missing is lambda. So you just substitute back, right? You just substitute back. Okay, you know the energy, or you can straight away use the C equal to F lambda also can, if you want. Actually the same. So you do substitution, at the end you arrive at 659 nanometer. Why at the end we write nanometer? Because in the chart given, usually is a scale in nanometer. This is to help us more easier to find what kind of radiation. Because the scale we usually see is in nanometer. Okay. So number C, we already clear. So as you can see from section A, section B, section C, if section A, your answer is wrong already. Let's say you write 3.02 10 power 9 or -9, you miss out the 1. It will snowball the rest. So wrong already. I don't need to mark already. I know it's wrong already. Because you are recycling the numbers from section A. So be careful. Always check your answer correct or not. Especially the index. Especially the index. If you're weak in indexes or you don't know how to use calculator, when they come to index, go and learn. Sometimes it's because you don't know how to use calculator. You press, wrong. Okay, so number 3 is release lah. You know it's release. Number 3, whether it asks you whether absorb or emit. So it's release, energy is emitted. So it's minus 3.2 10 power -9 joule. Joule. Again, you can say, Doctor, can I put EV here? Answer is yes. EV or joule is the same, right? It's the same thing. It's just different unit only. You need to only in the calculation just now in section B I mentioned. If you use Planck constant, make sure you use joule. That's a different only. Okay. So what series? This one from 3 to 2 is a Balmer. It's a Balmer. Okay. So I hope you understand this question, this tutorial question. Try to think what happened if the question reversed. Are you able to do? How the question can be reversed? I give you Balmer. I tell you, a hydrogen atoms belongs to a Balmer's type of emission. This is type of emission. So if I reverse this question, the question can be, the statement here already changed. Means at the end, you need to answer whether it changed from n from what to what. You need to calculate it changed from what lane to what lane. Okay. Now try to think whether you know how to do. If I reverse this question, I will tell you a hydrogen atoms belongs to a Balmer's type of emission. During the emission, the n position is at number 2. Actually, I don't need to mention number 2. If I tell you Balmer, you know that it stopped at number 2. It depends. If the question too long, I will remove the n number 2. The question will start with hydrogen atoms belongs in a reaction belongs to a Balmer's type of emission. Means you know that n equal 2 already. Plus the last station is stopped. Then it gives you the frequency, the wavelength of that and that. Try to find where does the hydrogen electron start moving from what orbit. The question asks you what orbit it start from. Okay. So the question can be reversed. So it still run around the general equation. C equal to F lambda, E equal to FH, Planck constant, E equal to minus 13.6, N equal to N square, and so on. So it just asks you, do you know how to apply all this equation? Okay, it's just important. It's just maybe some of this name is new to you, but the concept is there. Okay. Usually we'll ask you this 1, 2, 3, 4, 5 after these 5 names. P-Fan, Brackett, Paschen, Balmer, and Lehman. Either these 5. Okay, so I think we have a short break. We continue 9:05 lah. We have 10 minutes break. 9:05, we continue.